In this video, you're going to learn how to construct quadratic equations. As you already know, quadratic equations are equations of the following form: y equals ax squared plus bx plus c, where a, b, and c are constants and x and y are variables. I know that you have situations where y could take the value of 0, so that the quadratic equation will be 0 equals ax squared plus bx plus c, or ax squared plus bx plus c equals 0. So in general, the quadratic equation takes this form here, and then typically you also solve this equation for the case where y is 0, so solving this kind of equation. So normally you solve this kind of equation and you get solutions, you get valid values of x. So typically you get 2x values. So the first one I'm going to call x1, and the second x value I'm going to call x2. You know, in some cases the x values you get as the solutions can be the same. That's the case where you have repeated roots. But in this case, what we're trying to do here in this video is start from the solutions, these roots here, and arrive at the original equation. So normally you start from a quadratic equation and you get solutions. We want to start from the solutions and arrive at a quadratic equation. Let's quickly review the idea of solving quadratic equations. So for the following equation, 2x equals 0, this is an equation. It's not a quadratic equation, but it's an equation. Solving this equation means finding a value for the unknown variable that causes the left-hand side to be equal to the right-hand side. On the left-hand side here we have 2x, on the right-hand side here we have 0. So what values of x will cause this left-hand side to be equal to the right-hand side? What value of x will cause the left-hand side to be equal to 0? So the left-hand side is 2x, which means 2 times x. So what value of x can you multiply by 2 to give 0? Well, let's try some values. Let's try x equals 1. When x equals 1, what is 2x? So this is what I'll do. So on the left column here, I'm going to give possible values for x, and on the right hand side column I'm going to give the corresponding values for 2x. So when x equals 1, what is 2x? 2x is 2 times 1, which is 2. When x equals 2, what is 2x? 2x is 2 times 2, which is 4. We're trying to find a value for x that will cause 2x to be 0. Let's try x equals 0. When x is 0, what is 2x? 2 times 0, which means 2 times 0, which is 0. So which means that when x is 0, 2x is 0, which means that a valid solution for this equation is x equals 0. And that's the solution to this equation. So the idea of solving an equation is obtaining a valid value for the unknown variable that causes the equation to be satisfied. A valid value of the unknown variable that causes the left-hand side to equal the right-hand side of the equation. Now consider the equation of the form p, where p is a variable, times q, where q is another variable, equals 0. If I now ask you to solve this equation, what you need to do is determine values of p and q that will cause the left-hand side of this equation to be equal to the right-hand side of this equation. And just to show you what I mean, I'll show you an incorrect solution. So if I say when p is 1 and q is 1, the equation is satisfied. So this is an incorrect solution, because if you test it out, when p is 1 and q is 1, the left-hand side pq, which is p times q, is going to be 1 times 1. Is 1 equal 0? No. Therefore this here is an incorrect solution. This is an incorrect solution. But what if we say when p is 0 and q is 1, the left hand side, so I'll do that here. So when p is 0 and q is 1, p times q is 0 times 1, which is 0. So this equation is satisfied when p is 0 and q is 1. When P is, let's try some random numbers. When P is 3 and Q is 2, P times Q is 3 times 2, which is 6. Which means that this equation is not satisfied, because this equation is only satisfied when the value of P and the value of Q are such that the left-hand side is equal to the right-hand side. That is such that P times Q is 0. So far we've only found one valid solution for that equation. When P is 0 and Q is 2, and when P is 0 and Q is 3, you'll notice that P times Q is 0 in both cases. So what you notice is that anytime one of these values is 0, so anytime P is 0, P times Q is automatically 0, because 0 times any number is 0. So you can be rest assured that one possible solution for this equation is when P is, so I'll just cross this out, even though it's a valid solution, I'm just crossing it out. So this is what I'll do. For valid, I'll just note down the valid solutions. So you can be rest assured that when P is 0, regardless of what value Q takes, I can say, well, let Q be any real number. No matter what value Q takes, as long as P is 0, P times Q will always be 0, because 0 times any number is 0. So this is a valid solution. Another valid solution is the opposite case, where once Q is 0, no matter what value P takes, I'll put 1, I'll put 100, I'll put 2. 0 times 1 is 0. 0 times 100 is 0. 0 times 2 is 0. So provided Q is 0, regardless of what value P takes, so I'm using R to represent any real number, regardless of what real number value P takes, P times Q will be 0. So we have two possible solutions for this equation now. And I can summarize this by just saying, well, when P is 0 and Q is 0, this equation is satisfied. So when P is 0 and Q takes any value, the equation is satisfied. When Q is 0 and P takes any value, the equation is also satisfied.